So, lesson 65 is falling body problems. Acceleration, velocity, position. We've already talked about that relationship, yes. And that relationship is back. So, acceleration due to gravity. So, remember that nice number of 9.8 meters per second squared is your acceleration due to gravity. So, that is how the gravity is pulling things back down to Earth, right? Negative, the reason it says negative is because going away from Earth would be positive, coming back down to Earth would be negative. And gravity, of course, doesn't take things away from Earth, it brings things to Earth. And so that's the negative. This is negative since gravity is always pulling in the downward direction. So, and if gravity is negative, acceleration is negative. Now, position. The position function is given by, so this is a generic formula. H of t equals negative 4.9 t squared plus v of ot plus h of o. Now, v of o and h of o, do you know what that little o means on it? Not. What should it represent? The initial, right? So when you see that h naught or h of o, h of 0, whatever you want to read it as, okay, the science is h naught and v naught, right? It just means initial. So h of o is initial height. V of o is initial velocity. But that is your position function. Now, with that in mind, what do we get when we take the first derivative? Okay, so I heard there's two. I wasn't sure which way you guys would answer. So first of all, remember the first derivative of height or position is velocity, yes? So when it says h prime, remember that is the same thing as saying velocity. And when we actually take the derivative here, negative 4.9 t squared, you multiply by the 2, right? 2 times negative 4.9 is that negative 9.8, and it's t to the first when you subtract 1. Plus, what's the derivative of v naught times t? V naught or v sub 0. And what's the derivative of h naught or h sub 0? It cancels because, remember, v and h are just numbers, right? So that is velocity. H double prime. So what is the second derivative known as? Okay, acceleration. And what is the derivative of negative 9.8 t plus v naught? Negative 9.8. And notice, negative 9.8, acceleration due to gravity. So that position formula or height formula is what you can always use just based on basic acceleration due to gravity. We worked with some of these last time we worked with acceleration, velocity, and position. We worked with some of these where we started with 9.8 and worked our way back up. Okay, so now we're just kind of being more told that. Okay, a couple of things. If you didn't catch it, the negative 4.9 t squared became the negative 9.8, right? So it's there in order for acceleration to always turn out to be negative 9.8 meters per second squared. Helpful to know. Did you guys see this? Or negative 32 feet per second squared. You have to pay attention to what labels are used in a problem. If they're talking about something where gravity is important, and they talk about in terms of the traditional meters per second, then it's, yes, the negative 9.8. But if instead of meters, they say feet, think negative 32 feet per second squared. So good pieces of information to know. The v naught or v sub 0 is the velocity at time t equals 0, which is initial velocity. If the object is thrown upward first, then you have a positive initial velocity because your object is going up. If it's dropped first, if you're standing on top of a building and drop something, your initial velocity is negative because it's going down. And h naught is the initial height of the object. Like if it was dropped from the top of a building, it's the height of the building. If it's thrown from ground level, it's at 0 for ground level. If you're throwing it up or something.
Even if somebody who's, what if somebody who's like 5 or 6 foot tall climbs it? Would it be their height or just ground level?
General rule of thumb, they still consider it 0. I can't say you won't ever see some weird exception where they, take that into, tell you the height and tell you to take that into consideration. But usually, it's, for our purposes, if someone's throwing it from the ground, beginning level is 0. Does that make sense? I say that and watch something come up. But I don't remember anything in this book or anything coming up like that. So, okay, so let's look at some of these examples. An object is dropped from a height of 2,000 meters. Begin with the acceleration function and develop the position function. How far above the Earth will the object be 20 seconds later? Okay, so notice, what did it say to begin with?
It's dropped from the velocity.
Yes. My velocity will end up being negative. Yes. Okay. Now, notice it says to begin with acceleration function. Yes? What is our basic acceleration? Negative 9.8, right? So we're beginning with a of t equaling negative 9.8. Now, what did they say? They did say develop the position function, didn't they? Okay, I gotta be a little nitpicky when they say develop the position function. Because if they don't use the word develop, we could technically just take this formula right here, pick our initial height, our initial velocity, plug that information in, and go with it. If they say develop, you want to be careful that you can show how you got those numbers. Does that make sense? So, if we're starting with acceleration, okay, we're trying to work our way up to the position function. What do you know? Where do you go from acceleration? Velocity, right? And when we talk about that, velocity is the what of acceleration? Antiderivative or integral. So the velocity is going to be the integral of negative 9.8. Now, normally we say like a dx. Because we're talking in respect to time, and I'm going to use the variable t, I'm going to say dt. What is the integral of negative 9.8? Okay, so when you go up a power from negative 9.8, that basically means you're adding a t on, or your variable on. So negative 9.8t plus c. Now, this is where we have to be able to figure out or know the c. Okay. What do we know that it told us about velocity? Okay. If an object is dropped from a height of 2,000 meters. Well, first of all, what is that 2,000 while we're here? That's your initial height, right? That's your h naught. If an object is dropped, okay, so notice an object is not thrown downward. It is just dropped. So that means I open my hand, I release it. Did I give it any force? No. Okay, so what's that make my initial velocity? Initial velocity of 0. So I'm going to say my initial velocity, v sub 0, is 0. So velocity at time 0 is 0 because I didn't throw it. I didn't give it any push. I just released it. So what you can use here officially is that the velocity of 0 equals 0. So velocity at time 0 is equal to 0. So the point is, what's that going to make c? 0. Okay. And you could do that if you really want to by plugging in 0 for t and setting it equal to 0. but we're thinking it through there. So negative 9.8t, and then plus 0. And so that just means that overall, negative 9.8t. Okay, so it's velocity. After velocity, we need to talk about the height. Officially, how do we find height?
It's going to be the integral of
Okay, it's the integral of velocity. So it's the integral of negative 9.8t, and then, remember, dt. How do I do the integral of negative 9.8t? Add 1 to the power, so it becomes t squared, and then divide by that new power, so divide by 2. Negative 9.8 divided by 2. So if you really want, you could think negative 9.8 divided by 2, t squared plus c. But yes, realizing that cleans up to be the negative 4.9 t squared. What's my c going to be? If you look up above, it's going to be the h of 0. If I guess I should put something here. H of 0 is going to be equal to what? 2,000, right? So if h of 0 is 2,000, officially you can put in, excuse me, the 0 for t squared. It's plus c, and it equals 2,000. So you end up with the c being 2,000. Now, what were the questions they asked? I have to remember. Okay. Develop the position function, which, did we get the position function? Yes. My position function would be that h of t is a negative 4.9 t squared plus 2,000. I'm not sure which part of that was funnier. I am too, which makes, I can relate. My family picks on me about it. And then it said, 20 seconds later, what do I do?
What's that? 20.
Plug in 20, right? Because it's asking for how far above Earth, so that is height, yes? So if you do h of 20, you're plugging in that 20, and the calculator is going to do that math for us, right? Negative 4.9 times 20 squared plus 2,000. And so we get an answer of 40. 40 what? Meters. My recommendation, if you want to go this direction, you can think about finding the c by hand, but also realize we can use this basic height formula here, where v naught is going to go, initial velocity goes in front of t, initial height is added at the end. Questions there? I feel like maybe I shouldn't talk about the solving next time, just do it.
So far, I am not spooked.
You're not spooked, is that what you said? Okay.
At some point throughout the notes, each time I start worrying about
A ball is thrown downward with a velocity of 40 meters per second from a height of 2,000 meters. Begin with the acceleration function, develop the position function for the ball. What will be the position of the ball after 8 seconds? So, let's identify real quick. What can you identify in the given problem?
the velocity is not.
Velocity is negative 40 meters per second.
Okay. A ball is thrown downward with an initial velocity of 40 meters per second. So what is that saying?
V naught.
My initial velocity is going to be Negative 40 because it's thrown downward. So it's not just released. We've got a push behind it, right? What else were we given? From a height of 2,000 meters. So that is my initial height. Okay. Officially it says begin with acceleration and develop. What's acceleration formula? A of t equals negative 9.8. Nothing more to say there. How do I get velocity? In order to get velocity, we're going to integrate. So it's going to be the integral of negative 9.8 dt. What is the integral of negative 9.8 dt? Negative 9.8 t plus c. Guesses of what c is? That minus 40? Because officially we found v naught up there, right? V of 0 is going to equal to negative 40. So if you put 0 in for t and solve for c, c is going to be negative 40. So if you want, it's negative 9.8 t. You can say plus 0, or not plus 0. Wrong problem. I shouldn't be saying plus 0, I should be saying minus 40. Goodness. And what is that? Negative 9.8 t minus 40 is my velocity. Got acceleration. I've got velocity. How do I get position? Integral of velocity. So now I'm doing the integral of negative 9.8 t minus 40 dt. What is the integral of negative 9.8 t? Okay. Negative 4.9 t squared, because you add 2 and you divide by 2. Integral of minus 40, minus 40t. And then as always we say plus c. What do you think that c is going to be? Yeah, because officially if we take 0 and plug 0 in for t here and set this equation equal to 2,000. So I put in 0 and 0 and then set my equation equal to 2,000. C is going to equal 2,000. So that gives me the formula, negative 4.9 t squared, minus 40t plus 2,000. So officially that is my h of t. So one thing was develop the position function. So I got that. H of t is negative 4.9 t squared minus 40t plus 2,000. And then what did it ask me to find? Position after 8 seconds. So what do I do? Plug in 8. So we're finding, I am not writing what I want to write today. Keep writing. So we're finding h of 8. Have you guys done the math? Let me rephrase that. Have your calculators done the math? Okay, there's my calculator doing the math. 1366.4. 1,366.4 meters. All right, for example 3 when you are. what will be the position of the ball after 8 seconds?
I was like, where did that?
I just randomly made up. I liked the number 8 and wanted to use it. Okay. Anything else? Okay. A boy stood on top of a building 40 meters high and threw a stone so that it had an initial velocity of 20 meters per second. Begin with the acceleration function, develop velocity function, the position function for the stone. How high will the stone go? How long after the stone is thrown will it hit the ground?
So he's throwing it up?
Yeah, it doesn't give a direction. Well, since it's positive, I guess we assume it goes up.
It just says he threw the stone. It does not indicate downward.
Yeah.
So you would assume a positive here. It would have to give an indication of downward if that's what they want. But I can still throw it up.
What if he's throwing it straight out?
Right. But unless it's below that horizontal plane, I mean, even if it goes up a little bit, that's still going to be positive. So, yeah, we're going to go with the assumption of positive here.
Is that what you really want us to do?
Yeah. Unless it indicates that, that they threw it downward. Yes, that would be my thought. Okay. So, acceleration is negative 9.8, yes. That's the given. I guess here, we go through, did you guys identify everything? Initial velocity is going to be the 20. Initial height is
40.
the 40. Okay. So, acceleration, velocity then. What do we know about velocity? It's the integral of negative 9.8 dt, which is negative 9.8 t plus c. What's my c here?
That's the velocity.
Your velocity, right? So v of 0 is equal to 20. So this would become negative 9.8 t plus 20. Okay. Position. So height. The integral of negative 9.8 t plus 20 dt. Integral of negative 9.8 t, 4.9 t squared, plus 20 t. Officially, I'm going to say plus c, but this is height, and we know h of 0 would equal 40. So we plug 0 in for all your t's. C is going to be 40. So negative 4.9 t squared plus 20t plus 40. So height formula, h of t, negative 4.9 t squared plus 20t plus 40. Okay. How high will the stone go?
You need to solve for your time in the velocity equation.
Because why?
You need to get it to where the velocity is equal to 0, and then you can plug that time into the height equation. Because that's when it will hit the turning point and gravity overtakes it.
Okay. So what is happening if we throw this stone, okay? It was a stone, right? Whatever it was. If we throw this stone, what is happening at that highest point?
It doesn't accelerate. It doesn't have any velocity.
Yeah, the velocity has slowed down, and at that brief moment, that velocity is 0. Because it's going to go up. It's instantaneous, really, but then it starts going back down. So, we need to look on this question, how high will the stone go? We have to figure out when does velocity equal 0. Now, did we have a velocity formula? Yes. So we can use negative 9.8t plus 20 equal to 0. Your calculator can do the math here, right? Subtract 20 and divide by 9.8. 20 divided by 9.8, 2.0408 seconds. Now, does that answer my question? How high will the stone go? No, that answers, it's a time. That answers when my stone is at the highest height. So how do I find that highest height?
Plug it in.
Take this one and plug it into your height formula. So you're going to be finding h of 2.0408. So I can take negative 4.9 t squared. So honestly, I can just go up and grab that number from above and square it. I don't think it'll throw me off too much if I do this. Plus 20 times that number, and then plus 40. 60.4082. And this is a height, so it's 60.4082 meters. I don't know how much it would change if you had rounded your time. I don't know if it changes much or not, but okay. The girls are giggly for some reason. I'm not sure why, but okay. Last question. How long after the stone is thrown will it hit the ground? What do you know when a stone hits the ground?
Its height is 0.
Okay, velocity is 0, yes, but we just did the velocity equals 0, and that was the height up above. So we want to know, when does the height equal 0? So when does h of t equal 0? Do we have a height formula?
Yes, but there's a catch.
So we know that we're trying to figure out when negative 4.9 t squared plus 20t plus 40 equals 0. How do I solve this equation for t? Is this your catch? You don't know how to solve it?
I mean, there's that, but
If you do
you can factor negative 4.9. You can try to factor quadratic, which is faster.
Quadratic formula, here we go. It's not going to factor.
Since it's a trajectory.
So, quadratic formula, t equals negative b. So negative 20 plus or minus the square root, b squared, so 20 squared, minus 4 times a times c all over 2a. And again, calculator is going to do the work. So if I do a fraction bar, I can really just type this all in at once. Negative 20 plus the square root, 20 squared minus 4 times negative 4.9 times 40 all over 2 times negative 4.9. I get one answer of negative 1.4703. And then, because I don't want to retype that all, I'm going to go up and copy it. And I'm going to arrow over into my problem. And all that I really need to change is that plus to a minus. 5.55. 19, so 5.5520. So do we have two answers?
Technically, yes, but
What kind of answer is this?
can't have a negative time.
This is a time, and you can't, we're not going to talk negative time. So the negative's gone. 5.5520, what's my units?
Meters per.
Seconds. We're just talking about time at this point, so just seconds. So I'm hopeful that lesson seemed familiar. Yes, they said develop, so I tried to take you through the steps. But you realize, like for instance right here on this one, guys, negative 4.9 squared. If you look up at the beginning before we even start, that's the basic, right? V of naught times t. Was that 20 my initial velocity? Yes. Plus h of naught, initial height. Okay? Okay, guys.